In this video, we will be covering the 6 trigonomic functions in the unit circle. The purpose of the 6 trigonomic functions is to compare sides on a given triangle in correspondence with an angle. Sine, cosine, tangent, cosecant, secant, and cotangent. The symbol inside of the parentheses is theta. The purpose of theta is to represent a given angle. For sine, we have opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And a tangent equals opposite over adjacent. The reciprocals are hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. A good way to remember these functions is a saying called SOHCAHTOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. To find the reciprocal, it's just the opposite of the last 2 letters. In these 2 given triangles, we're going to find the difference and compare each side. We already know that the 90-degree angle is directly across from the hypotenuse, which is always the longest side. If my angle was up here, then directly across from it would be my opposite side. On this triangle, the opposite is over here. And the last side would be the adjacent, which is on the same side as the angle. Now let's try an example to find the 6 trigonomic functions on the given triangle. Automatically we know that 15 is the hypotenuse because it is the longest side and it is diagonal from the 90-degree angle. Since our theta is at the bottom, 9 would be our opposite side, and the last side remaining would be 12, the adjacent side. We know that sine equals opposite over hypotenuse, so that would be 9 over 15. Always try to reduce a fraction if possible. 9 over 15 can be reduced to 3 over 5. The reciprocal of sine is cosecant, which would be 15 over 9, which is reduced down to 5 over 3. A cosine is the adjacent side over the hypotenuse, which is 12 over 15. Reduced to 4 over 5. The reciprocal of cosine is secant, which is 15 over 12, which is reduced to 5 over 4. The tangent is the opposite over adjacent, and that is 9 over 12, reduced to 3 over 4. The reciprocal of tangent is cotangent, and that is 12 over 9, and reduced to 4 over 3. You should begin by labeling your sides: hypotenuse, opposite, and adjacent. And adjacent. Sine would be opposite over hypotenuse, which is 1 over the square root of 10. If you have a square root on the bottom of a fraction, you have to remove it. by multiplying the square root on the top and the bottom of another fraction. The square root of 10 over the square root of 10. The top would equal the square root of 10 over a square root times the square root removes the radical, so it would just be 10. And its reciprocal equals the square root of 10 over 1, which is the same as the square root of 10. Negative 3 over the square root of 10. Again, there's a radical on the bottom, so you would have to multiply it out. Your final answer would be negative 3 square root of 10 over 10. Its reciprocal equals the square root of 10 over negative 3. A tangent equals opposite over adjacent, and that would equal 1 over negative 3. And its reciprocal would equal negative 3 over 1, which is the same as negative 3. Here on the unit circle, we know that the circumference equals 2 pi. So halfway, or 180 degrees, would equal pi. At 90 degrees, it would equal, and at 270 degrees, it would equal 3 pi over 2, leaving this to be 0. In between 0 and 90 degrees, we can dissect this first quadrant, and that would equal pi over 4. At an angle smaller than that would equal pi over 6. And in between the 90 degree on the y-axis and pi over 4 would be pi over 3. An easy way to remember the coordinates for pi over 3, pi over 4, and pi over 6 are by starting with fractions. And then on the left side, you would go down 1, 2, and 3. And on the right side, you would go up 1, 2, and 3. And also, you would have to put the radical sign on the top of the fractions. So the square root of 1 equals 1, the square root of 3, the square root of 2, the square root of 3, and again the square root of 1 equals 1. And that is my conclusion on the lesson of unit circles and the 6 trigonometric functions.